Kohlrausch law. So let's see what is Kohlrausch law. The equivalent conductance of an electrolyte at infinity dilution is equal to the sum of the equivalent conductance of the components of the ions. So the formula for the Kohlrausch law, it is the lambda infinity is equal to lambda A, that is in equivalent conductance of a anion, that is lambda A, and lambda C, that means equivalent conductance of the cations. So this formula, it is known as Kohlrausch law. So next one, there is so application, some more application of Kohlrausch law. So the first application of the Kohlrausch law, so that is, so it is very useful to determine the degree of dissociation of a weak electrolyte. So for example, how can you determine the degree of dissociation of a weak electrolyte? So by using simply this formula, you can easily calculate the degree of dissociation of a weak electrolyte. So what is the formula? So that is alpha is equal to lambda V by lambda infinity. So where lambda infinity means the equivalent conductivity at a infinite dilutions. Lambda V means the equivalent conductance at dilution V. So the next application, though, the second application, so that is determination of equivalent conductance for the weak electrolyte at an infinity dilution. The second application of the Kohlrausch law. So what is that? So that is determination of equivalent conductance for weak electrolytes at an infinity dilution. That means how can you calculate the equivalent conductance at an infinity dilution of a weak electrolyte? Now here it is very simple. So by using the equivalent conductance of the strong electrolytes, then we can easily calculate the one of the equivalent conductance of weak electrolytes. So for example, if you see, for example, if you want to calculate the lambda infinity of the CH3COOH, then we can use the lambda infinity values of NaCl, HCl, and CH3COONa. So these are the strong electrolytes. So by using the strong electrolytes, we can easily calculate the equivalent conductance of the weak electrolytes. So remember this one. So in this case, what we are doing, we are calculating the lambda infinity of the CH3COOH, that is weak electrolyte. That means acetic acid. So by using the Kohlrausch law, we can write it as lambda infinity of HCl is equal to lambda H plus lambda Cl minus. So like that, lambda infinity of the NaCl is equal to lambda N plus lambda Cl minus. So like that, remaining that one lambda CH3COONa sodium acetate, the lambda infinity of the CH3COONa is equal to lambda of cation and anion. Yes, we know that. That is CH3COO minus plus lambda Na plus. So is it clear? Yes. So this way you have to write the lambda infinity and lambda for the cations and anions for the every single strong electrolytes. So by using this HCl, NaCl, and CH3COONa, then we can easily calculate the lambda infinity of the CH3COOH. Then how can you calculate? See this one. So lambda infinity of CH3COONa plus lambda infinity of HCl minus lambda infinity of the NaCl. So that is equal to, what is that? See this one, lambda infinity CH3COO minus plus lambda NH plus. So there is this one, lambda infinity HCl. So that is equal to lambda H plus Cl minus and lambda infinity NaCl is equal to Na plus minus lambda infinity Cl minus. So is it clear? So after writing the all the lambda infinity values of the strong electrolytes, then cancel the values if it is cancelled. Here in this case, uh, minus lambda Na plus and plus lambda Na plus is also cancelled, and remaining, so that is Cl minus lambda Cl minus and lambda Cl minus is also cancelled, plus and minus. The remaining what are they? Lambda infinity of CS3CO minus and another one, that is lambda infinity H plus. So after cancellation of the these values, then we can get the lambda infinity of CS3CO minus acetate, sorry, acetate, and also lambda infinity H plus. So these two values are equal to the lambda infinity of CH3CO minus. So finally, we can get the equivalent conductance of the CH3COOH at infinity dilution. So this way, you can calculate the equivalent conductance for the weak electrolytes. So next one, transport number. So next one, the transport number. So what is the transport number? So let's see. So during the electrolysis, so the current carried by the anions and cations, and the amount of carried by the each is proportional to the its speed. Yes, we know that. So if the U and V are represent the speed of the migrations of the cations and anion, then how can you write the fraction of the current carried by the its individual ions? So what is this? See, this one is U means U the speed of the cation, and V are the speed of migration of the anions. Then how can you represent the fraction of the current carried by the cation? See this one. So U by U plus V, U by U plus V, it is giving the information about the fraction of current carried by the cation. And whatever the anion, so V by U plus V, see this one. V by U plus V, it is the represent the fraction of current carried by the anion. So it is called as its transport number. So it is known as transport number, or it is known as the Ipsarp number. So it is denoted by the symbol. What is that? T. T plus means it is a cation transport number. T minus means anion transport number. Then now we can write the in the formula. See this one here, the transport number of cation T plus. So that is equal to current carried by the cation by total current. What is the transport number of the cation? Indicated with the T plus. So that is equal to current carried by the cation by the total current. So what is that? The current carried by the cation. So that is equal to U. Sorry, U by what is the total current? That is U plus V. So similarly, the transport number of the anion, that is indicated with the T minus. So T minus is equal to V by U plus V. V by U plus V. So here the fraction of the total current carried by the anion, it is directly proportional to the their velocity. Yes, we know that. Then here finally, if you add the T plus plus T minus, if you add the T plus plus T minus, so that is equal to 1 always. See, remember this one, T minus plus T plus or T plus minus T1, T plus plus T minus is equal to 1. So this is remember this one. So this is about transport number. So transport number means abhigamana సంఖ్యలు. అభిగమన సంఖ్య. అభిగమన సంఖ్యలు. మరి అభిగమన సంఖ్యలు అంటే ఏందో ఇక్కడ మనం చూద్దాం. సో ఎప్పుడైతే మనం విద్యుత్ విశ్లేషణ చెందించినప్పుడు అక్కడ మనకి ఏమైతుంది, ఇక్కడ అయాన్లు అనేటివి ఎంతో కొంత విద్యుత్తును క్యారీ చేయడం అనేది జరుగుతుంది. ఎంతో కొంత విద్యుత్తును అవి మోసుకెళ్ళడం అనేది జరుగుతుంది. ఏవైతే ఉంటాయో మనకు యానియాన్ మరియు క్యాటయాన్ ఉంటాయి కదా. సో ఇక్కడ అది మోసుకు వెళ్ళేటటువంటి విద్యుత్ పరిమాణం అనేది దేనికి మనకు అనులోమానుపాతంలో ఉంటుందంటే వాటికి సంబంధించినటువంటి వేగాలకు అనులోమానుపాతంలో ఉంటుంది. అంటే ఏంటి, ఏదైనా సరే ఒక విద్యుత్ విశ్లేషణ ప్రక్రియలో మనకి ఏమైతుంది, అయాన్లు అయాన్లు మోసుకువెళ్ళేటటువంటి విద్యుత్ పరిమాణం అనేది ఆ అయాన్ల యొక్క వేగానికి అనులోమానుపాతంలో ఉంటుంది. సో ఇక్కడ మనకు అయాన్ల యొక్క వేగం U అనేది క్యాటయాన్ యొక్క వేగం అనుకుంటే, అదే విధంగా V అనేది యానియాన్ యొక్క వేగం అనుకుంటే, మరి అది తీసుకువెళ్ళేటటువంటి పరిమాణం అనేది దేనికి సమానంగా ఉంటుంది అంటే ఇక్కడ చూడండి, U/U+V అనేది క్యాటయాన్ మోసుకు వెళ్ళేటటువంటి పరిమాణానికి సమానంగా ఉంటుంది. అదేవిధంగా మరి యానియాన్ సంబంధించి చూస్తే అది దేనికి సమానంగా ఉంటుంది, V/U+Vకి సమానంగా ఉంటుంది. సో దీనిని అంటే ఒక అయాను అనేది మోసుకు వెళ్ళేటటువంటి పరిమాణాన్ని మనం ఏమంటామంటే అభిగమన సంఖ్యలు అని పిలవడం జరుగుతుంది. అభిగమన సంఖ్యలు అని పిలవబడుతుంది, లేదంటే దీన్నే హిటార్ప్ నంబర్ అని కూడా పిలవడం జరుగుతుంది. సో దీనిని దేంతో చూపిస్తామంటే టీ చేత చూపిస్తాం. ఇక్కడ T+ అంటేనేమో క్యాటయాన్ యొక్క అభిగమన సంఖ్య, T- అంటేనేమో యానియాన్ యొక్క అభిగమన సంఖ్య. మరి ఇక్కడ T+ అంటే క్యాటయాన్ యొక్క అభిగమన సంఖ్యను ఏ విధంగా రాస్తామంటే, క్యాటయాన్ మోసుకు వెళ్ళేటటువంటి విద్యుత్ పరిమాణము అంటే U బై మొత్తం అయాన్లు మోసుకు వెళ్ళేటటువంటి విద్యుత్ పరిమాణం. ఓకే, సో దాని ప్రకారంగా మనం ఏం రాయొచ్చు, ఇక్కడ U/U+P అనేది దేనికి సమానం అవుతుంది, T+ కు సమానం అవుతుంది. సో అదే విధంగా యానియాన్కు సంబంధించినటువంటి అభిగమన సంఖ్యను మనం ఏ విధంగా రాయవచ్చు, ఇక్కడ T- ఈజ్ ఈక్వల్ టు D/U+V గా మనం ఇక్కడ రాయవచ్చు. సో T- మరియు T+ ఏంటి, అవి యానియాన్ మరియు క్యాటయాన్ యొక్క అభిగమన సంఖ్యలు ఇవి. సో వాటికి సంబంధించినటువంటి ఫార్ములాస్. సో ఇక్కడ ఈ రెండు అభిగమన సంఖ్యల యొక్క మొత్తం అనేది అంటే T++T- అనేది ఎప్పుడు కూడా 1కి సమానం అవుతుంది. సో అది గుర్తుంచుకోండి, T- అనేది దేనికి సమానం అవుతుంది, 1కి సమానం అవుతుంది. సో ఇది అభిగమన సంఖ్యలు. సో దిస్ ఇస్ అబౌట్ ట్రాన్స్పోర్ట్ నంబర్. దెన్ how can you calculate the transport number of any electrolytes? So there is one method, so that is called as the Hittarp method. So by using the Hittarp method, we can easily determine the transport number of any ion. So another one formula it is there. So that is number of gram equivalent seals. The number of gram equivalent loss from the anode component by the number of gram equivalent deposited in the voltmeter. So by using this formula, you can also find out what is the transport number of the anion or cation. So what is that? See here. To find out the transport number of the cation, you can use this formula. Then you can easily determine what is the transport number of cation. So let's see Hittarp method, the experimental procedure. So first of all, what is the operator? So in the Hittarp method, which operator it is used? See here. So in the Hittarp apparatus, so that operator consists of two limbed vessels connected by a narrow U-tube in the middle. See here. So see here, this is the Hittarp method operator. So these are the limbed tubes, glass tubes. See this. These two tubes are connected with a narrow U-type shape. See this. This is the narrow U-type shapes. So both limbs as well as the U2 are provided with the stop cops at the bottom of the withdrawal of the solution for the withdrawal of the solution. So here the two limbs are provided with the platinum electrodes. So in the every limbs of tubes consisting with the platinum. See, this is the platinum wire. The platinum wire acts as a electrode, cathode as well as the anode. So to determine the transport number of a silver plus, here what we are going to determine the transport number. So here silver plus cat and transport number. We are going to determine the silver plus transport number. So in silver nitrate, the electrodes are either of platinum or pure Hg are used in this type of method. So here, so another one, that is a silver or copper voltmeter is connected in series with the operator series one. So this is the voltmeter which is connected with the series of the circuits. So in this operator, see this one, fill with the standard solution of the silver nitrate, and cell is connected in the series with the source of the direct current. So this is the operator system. This one. This is a pit-top operator. And what is the procedure? Series. So here, what is this? So this is filled with the silver nitrate. Why we are filling the silver nitrate? To determine the silver flux series, silver plus transport number. Then what is the method here? After electrolysis, the solutions from the anodic as well as the central compartment are withdrawn and separately by the opening the stop box at the bottom and analyzed by the titration with the standard ammonium thiocyanate. So after electrolysis, then what happened? You have to take the solutions from the anodic compartment and anodic compartment. This one, you have to take the solution from the anodic compartment and the U2 shape component, and you have to find out the what is the amount of change, what is the amount of change it is takes place after the electrolysis by doing the titration with the standard ammonium thiocyanate. So in this way, you are you know the what is the change in amount of electrolyte in the anode compartment. So after that, how can you calculate the transport number of silver plus series? The conclusion, the concentration of the anodic solution after the electrolyte. So that is, say it is X gram equivalent of the silver is present after the electrolysis. So before electrolysis, say it is, let it be Y. For example, you take it is a Y gram equivalent of a silver. It is present before the electrolysis. Then what happened to the fall in concentration around the anode? Simply it is Y minus X gram equivalent of the silver. That is a fall in concentration around the anode. Next one, the weight of the silver deposited in the silver voltmeter. The weight of the silver deposited in the silver voltmeter, so that is equal to Z. Then what is the transport number of silver plus ion? The transport number of silver plus ion is equal to fall in the concentration of the silver around the anode by the amount of silver deposited in the voltmeter. Then substitute these values, these two values, then you can easily get the transport number of the silver flux. So what is the fall in concentration of the silver around the anode? So that is equal to Y minus X. And what is the amount of silver deposited in the voltmeter? So that is equal to Z. So finally, you can get the T Ag plus is equal to Y minus X by Z. Y minus X by Z. So this way you can calculate the transport number of the cations. So in this way, you can calculate the transport number of silver ion by using the Hitard method. So this is the Hitard method and transport number. So this is an important question for you in our examination. So they will ask. So first one, that is Kohlrausch law. That is also an important question. Kohlrausch law and this transport number and determination of transport number by using the Hitard methods. So these two questions are very important.